All right, so the applied deductive reasoning, that's what we're going to look at it. So in this one, now look at this logic, law of detachment. If the hypothesis of a true conditional statement is true, then the conclusion is also true. Like a lot of syllogism, like basically, if hypothesis
B. Didn't we learn this in logic class?
Yes, you do use this logic in the logical class. And yeah, it's really important in terms of like when you take the GRE, GMAT, those type of exams. But it's basically thinking, logical thinking, basically. If you look at this one, hypothesis is P and the conclusion is Q, and if hypothesis is Q and the conclusion is R, then what you see is like hypothesis is P and conclusion is R. Like for example, if this has happened and this is going to happen, and if this happens and this is going to happen, that means we can use a hypothesis to the conclusion. So that's a law of syllogism. It's really good way of thinking to kind of like look at the relation between them. We're going to see an example so it makes more sense to you. Amar, go ahead and read it.
If two segments have the same length, then they are congruent. You know that BC equals XC.
This equals XY. So this is congruent. So if you look at it, if two segments have the same length, then they are congruent. Then you know that BC is XY. So for example, if you look at it, so you can say this is, since a BC it's kind of like equal to XY, that says the hypothesis. The hypothesis says of the true conditional statement, which is conclusion also is also true, because it says the two segments have the same length. So, and we can say that's BC equals XY, or you can say it's BC is XY, and definitely we can say because they have the same length, we can say so BC, the line segment BC is congruent to XY. So basic logic behind that. Arjun, read the question.
Mary goes to the movies every Friday and Saturday night. Today is Friday.
So we need to tell whether it is a statement.
That means she's going to the movies.
Okay. First, we have to find out like which one is the hypothesis and what one is the conclusion. So what is the hypothesis in this?
Mary goes to the movie.
Hypothesis is if it is Friday or Saturday night.
Oh.
Okay. And the conclusion is then the Mary goes to the movies. Okay. So the hypothesis is like if it is Friday or Saturday night, and then conclusion, we can say that she's going to go to the movies. Okay, so now let's say if today is Friday, let's say today's Friday. Is that satisfies the hypothesis? And then we can say that Mary will go to the movie tonight. Does that make sense?
Yeah.
Okay. All right, Amar, go ahead, read it.
Okay. If Rick takes what happens to if Rick takes chemistry this year, then G would be Rick's lab partner. If G is Rick's lab partner, then Rick would get an A in chemistry. And so far, if the first two things is true, it doesn't maybe say it actually prove that he will get an A. It would just say if they have a partner, and she will be a partner. That's true. But it doesn't say Jerry is smart, so we don't know if he actually will get an A.
Okay. So in this one, basically, if possible, use the law of syllogism and to write a new conditional statements. Okay. So that follows from the pair of true statements. Let's say they give you two of the true statements. From that, you're creating a new conditional statement. Okay. So if Rick takes the chemistry this year, then Jesse will be Ricky's lab partner. If Jesse is Ricky's lab partner, then Rick will get an A in the chemistry. So there are two conditional statements. You see that as F, and then. And I'll say if, and then. So there are two conditional statements. So from this one, definitely we can see that we can see that the conclusion of the first statement is the hypothesis for the second statement. So you can write a new following statement. You can write a if Rick takes chemistry this year, here, then conditional statement, then Rick will get an A in chemistry. In chemistry. Does that make sense?
Yeah.
We create a new conditional statement with the given conditional statements. I have the if, and then this is the then. Okay? Does that make sense?
Yeah.
Okay. I'm going to give you guys an example. Let's try that one. All right, let's look into the next question. If x squared is greater than 25, then x squared is also greater than 20. The second statement is if x is greater than 5, then x squared is greater than 25. So go ahead and write a new conditional statement. I definitely like that. So if you look at it, if you take the first statement, let's say if I say if x squared is greater than 25, then x squared is greater than 25. So it doesn't make any good sense of that. You're already saying like
I was gonna say that, but I was like, that doesn't make any logical sense.
Right. So it's always better, let's say, what does it make sense or not? So obviously we can go, and the other direction of this is like if x is greater than 5, then x squared is greater than 20. So it makes sense, yes, it's good. So it's the conditional statement is going to be if x is greater than 5, then x squared is also greater than, it's going to be 20. That's going to be new conditional statement. Make sense? Arjun, read this one.
If a polygon is regular, then all angles in the interior of the polygon are congruent. If a polygon is regular, then all the sides are congruent.
I like that. So I can see that's how you use this. If a polygon is regular, then all the angles and interior are congruent. Oh, looks good. That's good.
What conclusion can you make about the project of an even integer and other integer?
Okay, so what conclusions can we come when we make about a product of the even integer and another integer? So we're taking one even integer and the other one is like different integers. It could be even or odd. So what kind of conclusions can we draw out of this? Okay, let's go try it and we can check through this. All right, let's look into an example here. So let me clear this. So what we can see is like, for example, obviously here is one of them is even number, right? Even integer. So when it says even integer, so obviously you guys know what's an even number is. So it could be 2, 4, whatever. So I'm going to take even integer is negative 2. I'm going to multiply with one odd number. Okay. So I'm going to multiply with this is even, and I'm going to take an odd number. So let's say 3. What I'm getting in there?
-6.
-6. Okay. So it's 6 is again even number. So I'm ending up with even number. What I'm going to keep it is like -2 still there, but I'm going to take a even number this time. So I'm going to take an even number is, let's say that's a 4. So what I'm going to get? Even number again? Yes?
Yeah.
Okay, so what if I take -2 is still there, and the other numbers are any other numbers, let's say 3 and 2.
Okay.
And I'm going to add more numbers like 3 and maybe I'll take 3 and 3. We'll see what happens. So what 3 times 3 is?
9.
9 times 2?
18.
18. So I still get the even
So
number.
it's always going to be even.
Even number. So your conclusion, I can say it's because, what conclusion can you make? So the product
If the product of an even
mhm,
then
of an even,
any other integer
yeah,
times that is even.
yep, integer and any integer is an even number or even integer. Does that make sense?
Yeah.
So that's our conclusion from this. So it doesn't matter what number you take, when you multiply with the even number, obviously you're going to end up with an even number. Now let's look into this question. And if two angles are vertical angles, then they have the same measure. You know angle A and B are vertical angles. And using the law of detachment, which conclusion could you make? Go ahead and try this. The vertical angles means, I'll show you quickly. If I draw a line like this and draw a line like this, these are called the vertical angles. This and this are the vertical angles. And I can say this, and then these are the vertical angles.
Okay, so yeah, they're equal to each other. We have class! Oh my.
So yeah, this is pretty good. So the first one is measure of angle A is and measure of angle B. They're equal because vertical angle is always the same measure. So that's good. And let's look at the next question. This is really a good one, and then it's really, put a star means a standardized test practice. Okay, so let an even integer is be 2n, and then odd integer is 2n plus 1. Explain why the sum of an even integer and then odd integer is going to be an odd integer. So go ahead and then try this one.
A even integer makes even, plus 1 makes it odd. Can I just say like that? If any integer times a even integer equals
I like the logic. That's good. Any even integer times even any integer times even. It's always even. Okay.
An even product. Then adding 1 will make odd.
Excellent. I like that. That's good. That's good. I like that reasoning out there. Or you can see this one also.
I feel smart. I feel smart saying that.
Well, that's good. That's good. That's what we want to hear it. Like you want to be, feel confident. That's our priority. So now looking at this one, obviously an even number is 2n. Okay. And then we are adding, right? Adding to odd integer. Odd integer is 2n plus 1, which is 2n plus 1. So if I'm adding this 2, eyes up here. If I'm adding these two, what I'm going to get? That's going to be 4n, which I can divide it 2 times 2n plus 1. I know, as you just mentioned right here, 2n is a even number. But any number you multiply by 2, I'm going to get even. Even plus 1 is always odd. Okay? Yeah, that's a good one. Okay, next. So what we're going to do is we're going to reason from a graph.
Okay.
From a graph. So we're going to see what kind of conclusions can we make out of a graph. That's what we're going to see. Now let's look into the next one. We have a graph here, and we need to come up with some conclusions out of this graph. Arjun, please read it.
So tell whether the statement is the result of Deductive reasoning or deductive reasoning. Explain your choice. A. The northern elephant seal requires more strokes to surface the deeper it dives. Then B. The northern elephant seal uses more strokes to surface from 60 feet than from 250 feet.
Okay, so now look at this graph and then see what kind of conclusions can we draw out of that.
Okay.
So if you look at the first one, the northern elephant seals requires more strokes to surface the deeper it dives. So if you look at this deeper, if you look at the distance right here, the depth, and you see this like as it goes more from 200 or from 0 to 100, 200, 300, you see the more data points, right? There are like more data points up here. So this is the inductive reasoning. It is inductive because we are bringing the conclusion from the pattern of the data, from pattern in the data. Okay, so in the data we have, you can see that one. Literally, you can see that collecting data, we can see the collect data, and from that we draw the conclusion. So that's the inductive reasoning. And the second one is, so you can see this northern elephant seal uses the more strokes to the surface from 60 feet than from 200 feet. So here, this is a deductive reasoning. Deductive reasoning. So the reason behind, so you're comparing two values only, 60 feet and then 250 feet. You're comparing just the two values. So it is a deductive reasoning. Does that make sense?
Yeah.
So just comparing two values.
Okay.
That's the reason it is deductive. But the inductive is like, you see the pattern, it's like a couple of points, and that's the reason that's from the inductive. All right, let's look into a really good question here. It's based on a real, what you can like application here. You can see the Phoenix, Arizona, Mexico, Colorado. That's the reason this called as the four corners. Okay, so go ahead and read this one and let's try. So let's try to understand this one a little bit more so it makes more sense to us. So watch this quickly.
Deductive, inductive.
Just a minute.
What's the difference? Deductive reasoning starts out with a hypothesis and examines the possibilities to reach a specific logical conclusion. For example, spiders have 8 legs. A black widow is a spider. Therefore, a black widow has 8 legs. Think of it as a mathematical equation. A equals B, B equals C, therefore A equals C. For deductive reasoning to work, the hypothesis must be correct. It's assumed that the premises, spiders have 8 legs, and a black widow is a spider, are true. So the conclusion is logical and true, because in deductive reasoning, if something's true of a group of things in general, it's also true for all members of that group. However, even if the generalization is not true, it's possible to come to a conclusion that sounds logical, but may also be incorrect. If I say all spiders eat fish, a black widow is a spider, therefore black widows eat fish. It's valid logically, but it's untrue, because the original statement is false. Inductive reasoning, on the other hand, makes broad generalizations from specific observations. There's data, then conclusions are drawn from the data. Here's how it works. A coin that I pulled from this bag is a penny. A second coin is a penny. A third coin is also a penny. Therefore, all the coins in the bag are pennies. But inductive reasoning allows for a conclusion to be false even if the premises are true. For example, cobras are venomous. Cobras are snakes. Therefore, all snakes are venomous. Inductive reasoning may not always produce a true conclusion, but scientists can use it to produce hypotheses to investigate. And they use deductive reasoning to apply the hypotheses to answer specific questions about science. Deductive and inductive reasoning. But wait!
So basically, they always draw conclusions. and from the conclusions we can create a hypothesis. From the hypothesis we can come up with some conclusions too. So that's basically inductive and deductive reasoning. So how do you feel? Is it all right now? Makes sense a little bit?
Yeah, it makes it much more
That's
sense.
good.